On the next page, page 12, we have another proof, and so we'll be adding markings and detail to this proof as well. We start with the given statement that AB is congruent to CD, exactly the same size. And we also have the statement that BC is congruent to DA. Now that ultimately is enough to jump to the fact that the whole figure is a parallelogram. But we're trying to be clear about why it's enough for the figures to be a parallelogram. So we want to get to the idea of what it means to be parallel and how we know we have parallel in the figure ABCD if we're given these two pieces of information. So look at number one. AB is congruent to CD and BC is congruent to DA. That's right there in the given statement. I take the information that AB and CD are the same, and so I colored it orange because I wanted to make sure that they stood out. And then also there's a single spike on those two lines. The same thing is that BC and DA are the same, so they're colored green just to make sure they stand out. And I put two spikes on those two. The reflexive property is the reason that this line in the middle that goes from point B to point D, that's a line that's shared by both triangles. It cuts the parallelogram shape in half. Now we don't know it's a parallelogram yet, but it cuts the parallelogram shape in half. And so there's one half over here and it makes a triangle. And there's one half over here and it also makes a triangle. And they have this line BD in common. So statement 2 says BD is congruent to BD, and that's because of the reflexive property. Well, what that means is that there's a triangle DAB. So point D, A, B. This makes a triangle. And it's congruent to the other side, the other triangle DCB. Those two are the same. It's because we identified a pair of sides, a second pair of sides, and a third pair, although it's the same line, a third pair of sides, as in SSS, triangle congruence. So then we can consider some of the pieces. CPCTC is an abbreviation that stands for corresponding parts, like the ones that match, of congruent triangles are congruent. So looking at the diagram, angle 1 is congruent to angle 3. That's this angle 1 over here with angle 3. They're the same size. We have congruent triangles, so that means that there has to be congruent angles in both of those triangles. Angle 4 is congruent to angle 2. So this is angle 4 and this is angle 2. They're both the same. That gives us a pair of angles and another pair of angles that are congruent. Well, because the angles are congruent, that actually gives us a zigzag. So zig to zag, angle 3 and angle 1, or zig to zag, angle 2 and angle 4. If you get angles that are in the corners of the zigzags, they're alternate interior angles, and we set up here in statement 4 that they're congruent. So if that's the case, the green lines, AD and BC, these green lines, they're parallel. These orange lines, AB and DC, they're parallel. And you know what? If your sides are parallel, you have a parallelogram.